Good morning. First, let me thank the organizers, especially Dr. Akbar Irani, who has been so instrumental in helping us see these volumes of the Mu'miniyeh to fruition. I also want to thank Professor Hussein Masoumi Hamadani, who was also very helpful throughout the editorial and publication process. Let me also thank our colleague, Professor Hanif Andari, for all his support. Of course, my greatest debt is to my two colleagues and co-authors, Fatima Savadi and Sajed Nikfahm-Khubravan, who have evolved from exemplary students to the most patient of teachers. I have learned an extraordinary amount from both of them. Over 40 years ago, I stumbled upon Danish Peugeot's facsimile publications of Ṭūsī's Mu'miniyeh and its appendix, the Hal. They were a revelation. It was obvious that Ṭūsī had developed some of his astronomical models long before writing his Tadhkirah, a work that I was then in the process of editing and translating. Also obvious was that these models were developed in Persian and at an Ismaili court. The received wisdom that Persian was at best of secondary importance as a scientific language had to be rethought. Also, we had to consider that Ṭūsī's important work was done long before his coming to Maragha. All myths die hard, and we still contend with phrases such as Arabic science and, quote, the Maragha school. But hopefully, these publications of the Mu'miniyeh will help put some of that received wisdom to rest. Let me now turn to the Ṭūsī couples, which there were more than one, and their connection to Copernicus. Ṭūsī claims in the Mu'miniyeh to have developed a method of dealing with Ptolemy's violations of uniform circular motion. But he says he has to postpone them, saying that he's waiting for the Prince of Iran to encourage him to publish. This was his patron, Mu'in ad-Din, what the Mu'miniyeh is named after. So we don't really get anything in the Mu'miniyeh itself. His proposal, the first account of the Ṭūsī-Couple, occurs in the appendix to the Mu'miniyeh, the Halli Mushkilati Mu'miniyeh, which was written in 643 of the Hijra, 1245 of the Common Era, a little over a decade after the completion of the Mu'miniyeh. And you see the date here, 643. The Mu'miniyeh itself, the Hal is a kind of collection of notes about various things in the Mu'miniyeh that he wants to expand on or correct. The Ṭūsī-Couple occurs in chapter 3. He also has some interesting things to say about Ibn al-Haytham's latitude theory in chapter 5. But the proposal in the Hal contains only the rectilinear version of the Ṭūsī-Couple. Here we can see on the right side. This is the one that produces straight line motion. Now, this was used by Ṭūsī to reform Ptolemy's longitudinal motions for planetary motion. These would be longitudinal models for planetary motion. We can see here the lunar model. This is also in the Hal. It's noteworthy that this lunar model actually contains an error, a mistake. Now, what you can see here that the mistake has to do with what he calls in the hal, the inclined orb, which is the combination of two orbs in the tadhkira. It should be 13 degrees 14 minutes. In the hal, he has it as 13 degrees 11 minutes, which is a mistake. Now, in addition to this mistake, we can also say it is clear that at the time of writing the hal, Ṭūsī had not yet developed his curvilinear Ṭūsī-Couple, which, among other things, was used to reform Ptolemy's planetary models. Instead, he presents Ibn al-Haytham's models, which are basically a physicalization of Ptolemy's latitude models without resolving their various problems. Among these was a disruption of motion and longitude. In other words, Ptolemy's models, in addition, when they take into account latitude, also disrupt the longitude of the planet. Ibn al-Haytham's models do nothing to correct that. Now, a year later, after the hal, this is 644 Hijra, 1247 Common Era, Ṭūsī, in his recension of the Almagest, used a mathematically equivalent variation of his rectilinear Ṭūsī-Couple to deal with Ptolemy's latitude models. But again, the problem was that what was needed was an oscillation along a spherical arc, not rectilinear oscillation in a sphere. In other words, to resolve the latitude problem, you needed motion along an arc, a spherical arc, whereas the rectilinear Ṭūsī-Couple only produces straight line motion in a plane. Now, Ṭūsī did not present his curvilinear Ṭūsī-Couple, which can produce almost straight line motion on a spherical surface, until he completed the Tadhkira fi Ilm al-Hay'a in 659 Hijra, 1261 of the Common Era. Now, several things to keep in mind here. From the announcement of his proposed reform of Ptolemy until his final presentation in the Tadhkira, this period spans some 25 years, quarter century. Ṭūsī was testing different solutions for dealing with latitude theory over that entire period, not coming up with a satisfactory solution until he wrote the Tadhkira, as we've seen. Now, even with his early longitude models, Ṭūsī was not in complete control over what he was presenting, as is evident from the mistake he made in the lunar model in the hal. What conclusion can we draw from all this? The development of these alternative models took considerable time and effort. There were also several variations of the Ṭūsī-Couple. This is important to keep in mind when assessing claims that it was, quote, natural for someone to come up with these models. Now, let's turn to the connection with Copernicus. In De Revolutionibus, which was published in 1543 of the Common Era, Copernicus uses the two equal circle version of the Ṭūsī-Couple, this right here on the right, which is basically the same as what Ṭūsī had used in the Tahrir al-Majisti, the recension of the Almagest. Now, Copernicus uses this for the inequality of the precession of the equinoxes and the variation of the obliquity of the ecliptic. Without going into great detail on this, he has one Ṭūsī couple which he can then vary the speed at which precession occurs. We now know this is a mistake, but at any rate, he wanted the precessional rate to vary. And Copernicus also uses another Ṭūsī couple set to change the obliquity, that is the tilt of the Earth axis to its motion around the sun. Now, he also uses it for oscillation of the orbital planes in the latitude theory, and finally, for the variation of the radius of Mercury's orbit. This is, we can see two versions of this, one in the earlier Commentariolus and the other in De Revolutionibus. You can see here the Ṭūsī couple is being used to vary the distance to the sun in the Commentariolus. In De Revolutionibus, it's used to vary the distance to the center of Mercury's orbit. Now, in the much earlier Commentariolus, it is the truncated two-sphere curvilinear version that is used for the latitude models. And it is the physicalized rectilinear version that is used to vary the radius of Mercury's orbit, but in a truncated two-sphere version without the enclosing maintaining sphere. Now, to understand that, we need to see that if you take the mathematical Ṭūsī couple and physicalize it, you need to have a way to have the resultant motion not be disrupted by something called an enclosing sphere. So let's say you have an epicycle here on the left that you wish to go up and down a straight line. You need the enclosing sphere to move in such a way that it keeps the epicycle correctly aligned. You also need an enclosing or maintaining sphere for the curvilinear Ṭūsī couple. Now, the point is here that in neither the Commentariolus nor in De Revolutionibus do you have the complete Ṭūsī sphere models with the enclosing spheres. In conclusion, it seems that Copernicus was attempting to provide actual spherical models for the two versions of the Ṭūsī couple that he uses in the Commentariolus, but he is using the truncated versions that actually don't work. In De Revolutionibus, Copernicus abandons any pretense of full physical models for his Ṭūsī couples and instead relies on the two equal circle version, which is a mathematical, not a physical model. Now, there have been a number of claims that Copernicus did not receive the Ṭūsī couple through Ṭūsī or other Islamic sources. It has also been claimed that he invented the couple independently, but those positions, I think, are problematic. As for the first one, the fact that he invented, I'm sorry, that's the second, is that he didn't invent, he invented them himself. Copernicus himself refers to some other people who have used the Ṭūsī-Couple, so it is clear that he is not claiming priority or independent invention. Now, in De Revolutionibus, Copernicus refers to Proclus, a late antique Greek writer, in connection with the couple. So some have claimed that this is his source. But this reference is late in Copernicus's career and does not take into account that Copernicus used both versions of the couple 30 or more years earlier in the Commentariolus, long before Proclus's commentary on Euclid would have been available to him. Also, Proclus refers to a way to make circular motion from straight line motion, which is the inverse of what the Ṭūsī-Couple does, which is create straight line motion from circular motion. So it's not even the same thing as a Ṭūsī-Couple. On the other hand, Copernicus could well have seen diagrams of the Ṭūsī-Couple and the Hull version of the lunar model when he was in Rome during the Jubilee year of 1500. During that time, he may have been an apprentice at the Papal Curia, which would have given him access to the Vatican Library, which contained at least one, perhaps two, copies of a work called Schemata of the Stars, which was written by a Byzantine scholar named Gregory or George Chioniadis. It is beyond doubt that Chioniadis based his work on Ṭūsī's Monnier and Hull, which Chioniadis studied while in Tabriz in the 1290s at the court of the Mongol ruler Ghazan Khan. The reason we can conclude this is that the schemata has a lunar model which is identical with the one in the Hull, which is here in the middle, and namely that it contains the same mistake that we saw earlier in the Hull. That mistake is also contained in the schemata of the stars, which is different than what one finds in Ṭūsī's Tafkira here on the left. Now, there are other possible ways in which Copernicus may have learned of the Ṭūsī-Couple. I don't have time to go through all of these. I'll just leave the slide up for you. And these are various sightings of the couple in European sources before Copernicus, and these may have well been sources for Copernicus's knowledge of the Ṭūsī-Couple. But in all cases, we can fairly definitively say that Ṭūsī was the originator and that other people in Europe were somehow aware of his new invention. So let me conclude then, and thank you to the organizers, and wishing you all well. Thank you very much.